somebody. Welcome back, everybody. Notes using greatest common factor. We talked about this before. We started the notes. Go ahead and be quiet for me. We got GCF, right? Make sure you know GCF, GCF, GCF is greatest common factor. It is the biggest thing that everybody's got in common. And so, question like number 1, question like number 2, you know what? We can do the GCF of these questions very easy. Okay? We go to Desmos. We use the nice little code GCF parentheses, and then we type them with a comma, 6, 3. Desmos does the hard work, and we should have 3 for question number 1. Then we look at the x's, and you know what? I see 1x and 0 x's. Our second person has no x's. So what do they have in common? No x's. So 3, that's as good as it gets. Now, let's look at number 2, and we're going to come back to number 1, but let's look at number 2 really quick. 54 and 24. Okay, backspace, 54, 24. Desmos says 6. And how many x's should be on this 6? There's 2 and 9, and the smallest number is 2. So we're going to choose 2. Okay, now here's where you need to listen to me a bit, because here's where we're going to see something new. This is exactly what we did on the warm-up. This is GCF, but we haven't done this yet. Factor. Okay, so here's the factoring part. What we have figured out is how much everybody can donate, and here's what we need to do. Figure out what is left after we give this stuff away. Okay, so we started off with a 6x, and we decided that we could donate a 3. Okay, well, once we give away that 3, what's left? So the way that we write this is we follow up the GCF with some parentheses, and because we have kind of like 2 kids at the start of the question, we need to have room for both kids at the start of this question. And from here, we're going to use dividing. So when you see this on the board, when you see this on the paper, this probably reminds you of distributing, right? The 3 with the parentheses, and it probably makes you think, oh yeah, distributing, it could look like this. What we're doing is actually the opposite of distributing. What we're doing is actually undistributing. We're going backwards. We're doing anti-distribute. We're doing, undistribute is really the best way to say it. And so if we're doing the opposite of distribute, and distribute is normally a multiply, that's why when we do this, we need to use divide. So, really simple. We're going to do our GCF, which we're very good at, which is very easy, and then we're going to do divide, which we're also pretty good at. Not really much else. Okay? So we want to divide by 3. What is 6 divided by 3? 2. And that person started off with an x. Are they going to donate their x away? No, they're not going to donate their x away. So they're going to keep their x. And then this last one is 3 divided by 3. 3 divided by 3 is 1. So 3 divided by 3 is 1. Okay. So that is the end of our question. I'd appreciate, especially when these questions get a little bit harder, if you guys in the back would maybe stop talking quite as much. What we have for this question, thank you for being back in time. Again, when you finish, it should look like a distribute question. But our answer is how the old questions used to start. So let's do number 2. Let's kind of, get back into it. We need parentheses following the GCF, and we should have 2 positions for those 2 kids. And we want to figure out, okay, once we give away the 6, what's left over? What is 54 divided by 6? If we're not sure, Desmos, you're correct. 54 divided by 6 is 9. So we're going to put a 9 here. And this first kid has 2 x's, but we determined that we're going to be donating 2 x's. We're going to be, 2 minus 2. Because when you divide the letters, you use subtraction. So 2 minus 2 is 0. This kid right here should have no x. He gave them all away, right? Oh. Super generous, right? Nice guy. Gave away all the x's that he had.
Subtract the x's then?
Yeah, because it's like 2 minus 2. When you do division of variables, it's like subtraction, which is weird, but it's what we did this week. Okay. Now the second part, 24 divided by 6 is 4. Right, and maybe we even put negative 24 divided by 6 so that we get negative 4. My bad if I confused you there. And now, how many x's should that person have? 7. Of course, that's not very hard. We started off with 9, and they're giving away 2. So they've got 7 left. It's just 9 minus 2 makes 7. This is the question. Again, it should look like a distribute question. It should look like, hey, if I distribute this, that would work. Okay, let's do 2 more questions, then we're going to pause for just a second, and then we're going to finish out the paper. Number 3, 7, and 10. You tell me, what's the GCF? 7. Nope. 1. It is 1. And then let's look at the x's. We've got 3 and 1. What's the greatest common factor? It's only 1. Because we picked basically the smallest number. Now, why would it be called greatest if we pick the smallest number? Because we're looking for the greatest common factor. So there's sure one really rich guy who's got 3 x's. But everybody's got 1 x. The common factor is 1.
There's like each has at least 1?
Right, exactly. That's exactly how to think about it. How much do we all have? Okay, now finish this off by doing the factoring part using divide. What is 7 divided by 1? 7. What is x cubed divided by 1 single x? X squared, because everybody's going to give away 1, so he's going to go from 3 down to 2. And the last guy, negative 10 divided by 1. Dividing by 1 doesn't really do anything to the numbers. 1x, and everybody's going to lose 1, so this person should have no x. All right, any issues with number 3? We feeling okay? All right, we're going to do one more, then we'll pause for a second, and then we'll knock these out. So for number 4, I'm going to write this just a little bit different. 24 and 8, we can use GCF. Let's, backspace, clean up my Desmos a little bit. 24 comma 8, which is 8, okay. I'm going to put the 8 down here a little bit more. And then we've got 2 x's and 1 x. 1 single x is the GCF. Now sometimes, in order to kind of remember what they're supposed to do, teachers will kind of show you to write it like this. Divide by 8x, divide by 8x. That way, it becomes very clear both of these need to be divided by 8. That's something that it helps out some people. It's kind of extra writing and makes it look more complicated for some other students. So if you don't want to write these, you don't have to write these. If you've been confused so far, I would recommend, once we found 8x, we're just going to put these little divided by 8x parts. So now 24 divided by 8 makes 3. So we did that. X squared divided by a single x is going to be 1x. So we did that. Negative 8 divided by 8 is negative 1. And x divided by x, it's going to be no x. So if you're feeling like, okay, I get the GCF part, and dividing's not that hard, but I don't really know what I'm supposed to divide, sometimes writing these little minus 8x parts can help you out. Okay, now I said we're going to pause for just a second. Here's what I want to kind of show you or ask you, okay? These look like dividing questions. Sorry, wrong D word. These look like distributing questions. So, what would happen if we distributed? What would happen if I took this 3 and I distributed it into the parentheses? Well, what's 3 times 2? 6x. And what's 3 times 1? 3. And what is this? It's the question that we started with, right? The question started 6x plus 3. We pulled the 3 out. If we put the 3 back in, it would be a big circle. We'd be right back where we started, right? This is like if you added 1 and then subtracted 1 to a number, right? If I said, hey, how old are you? 15. Okay, cool. Add 2 minus 2. How old are you now? You're still 15, right? You can't do two opposites. It's not going to do anything. So because we are undistributing, if you undistribute and distribute, you're going to be right back where you want, right? Nothing's going to happen. So, if you undistribute, pull the 3 out, and then redistribute, put the 3 back, and you make a perfect circle, that means you did it right. This is a good way to check your answer. This is a good way to kind of, hey, I did this question and I'm not sure if it's right or not. Well, do a little distribute. That doesn't take very long, and you can tell if you're right or wrong. All right, last 4. Here we go. We're going a little slow. We're going to pick it up. GCF. What's the GCF of 10 and 15? 5. How many x's do we have in common? 2 and 1 means 1. 1 and 2 y's means 1. Now, we can think about pulling out the 5xy, and what is left behind? What is 10 divided by 5? 2. We had x squared, but we lost an x. Just 1. We had a y, but we gave it away. So this first person has no y's, right? And you don't have to write, you don't have to write this. But if you want to, you can. We should have no y for this person. The second term, negative 15 divided by 5, you guys tell me what that is. Negative 3, they had 1x, but they lost 1x. So this person has no x. And then 2 y's, you lose 1 more, and so you should have only 1. And if we distributed this, we should get right back to where we started. All right, we're going to do number 6 together, then I'm going to use some random number generators to see how 7 and 8 go. Doing number 6 together, first of all, looking at these numbers, Desmos, GCF, 12, 9, 15. 3. 3 is our GCF. Well, thank you for folding up a tiny little note for me. Appreciate that. Oh, nice. It's a culminating assessment. I'm so glad he sent me this small missive that I could. Here, I'll keep that for later.
When did we do that?
All right, so we got the 3. Now let's look at the x's. How many x's are we gonna pull out of this equation? So we've got 2, 1, and 0. This 15 has no x's. Can all 3 kids afford to give away an x? This 15 cannot. So this is all that we're giving up. That's it. We're not taking out any x's. That actually makes this question super easy because that basically means don't touch the x's. Don't change the x's. Malachi, that is ridiculous and insulting in a way. 12 divided by 3 is 4x squared. Negative 9 divided by 3 is negative 3. Don't touch the x. And 15, which has no x's to give away anyways, 15 divided by 3 is 5. All right, there you go. That is question number 6. Okay, I'll give you a little bit of time. See if you can work ahead. Number 7, maybe number 8 as well. I'm going to call on quite a few people. The chance that you get called is honestly pretty high. You got a question, Miss Sarah, or you just got answers already?
Can I get water?
Get some water? Yeah, I'm cool with that.
You check one.
Yeah, bring it up here. I'll give you another little bit of a head start, and then I'll call my first victim. I mean, volunteer.
Yeah, that's pretty weird, Mr. Coyer.
You like that? Oh, that's pretty weird.
You like that?
Yes. This one? His paper? Yeah, I can keep this one. Why? So nobody passes it around? SMH. All right, let's see. Number 7. So for this question, number 7, we're looking for the GCF. Random number generator, 16. Person number 16 is KK, who was so excited to get called on earlier. KK, did you fall asleep during the notes? Oh, she's back. KK, did you get the GCF for number 7? With 3, 12, and 30. It is 3. Excellent job, KK. Way to go. What about the ends? How many ends is our greatest common factor? Person number 18, which is you, Misair. I've got your paper right here. You said 1 N, and you're correct. Nice job. We're going to be GCF of 3 N, and then we got 3 kids left. Let's see what they have left over after they generously donate their stuff away. So the first kid, can you tell me the first term, the whole piece, person number 8? Janaya. You know, we were doing notes and you were following along and you were focused and you weren't distracted. You got this first term here? 1, and how many n's on that one? 1 n squared. Very good job, you know, absolutely locked in. I appreciate you. Up next, can you tell me this middle person, number 18? We're going back to Misair's paper. Let's see what he's got. He has 4n. Anybody agree with that? As long as it's a negative 4n. That is what he had. Nice job, Misair. Way to go. The last one, can you tell me this person, number 6? Devin, you got this, man. What do you got in this last spot? So we got to do 30 divided by 3. right? Because we're here. 30 divided by 3. 10 minus 10. And then we have an n, but we need to get rid of one n. So how many n's should the 10 have? 0. Perfect. This is the answer. We all work together. 3n parentheses 1n squared minus 4n minus 10 with no n's. That is the answer. All right, last one here. Last one. We're almost done. It's almost lunch. 18, 12, 24. I'll give you 30 seconds of a head start. Try to get it down. Let's see how Misair did. All right, let's see. We're going to ask person number 9, Brandon. Did you get the GCF number yet?
Yeah.
What'd you get?
6.
6 is correct. Well done. 8, 12, 24, 6. Perfect. What about the letters? Did you get the letters already, Brandon, as well? How many x's should be on that 6?
X2, Y2.
X squared, Y squared is correct. Very good job, Brandon, and very impressive since you weren't here yesterday. I am proud of you for being so locked into these notes. All right, now we got to figure out these last 3 terms. We're giving away a lot. We got a very generous family. Everybody gets divided by 6. Everybody gives 2 x's away. Everybody gives 2 y's away. So, person number 15, which is Malachi. Malachi, can you help me out with this first term?
The number?
The whole thing. You got the whole thing?
Like 3?
3 and? How many x's? Started with 2, but also gave away 2.
That'd be like no x's.
Correct? Started with
Y squared.
4 y's, got rid of 2. You're right, y squared. Nice job. Handwriting's a little messy there. Y squared. We got 2 more terms. Person number 3, Josh, you got the middle term for me? Negative 2y is correct. We gave away both our x's and 2 of our y's. And the very last term, the very last thing, person number 5, Marcos, you've finally been chosen.
Plus 4.
+4. No x's, no y's. Perfecto. Excellent, excellent, excellent. Well done, everybody. This is factoring. I'll tell you, factoring is what we'll be doing for a while. And it's going to go from, okay, this wasn't that hard. And it's going to slowly get harder and harder and harder. Eventually, factoring will be something tough. But for right now, we want to make sure we're really good at this so that much of the factoring is locked down. Remember, what we're doing here is just undistributing. We're just pulling out as much as we can. And if you did another distribute, it would be a nice big circle. You would get right back to your answer. All right, that's the notes for today. Excellent job.